Okay, hello guys. So it's been quite a long time, okay, and we haven't made any video and we haven't done anything as such. So I believe that it's time now that we should start from a new subheading, isn't it? So as the chapters are not very much this year, okay, so but it's our duty to do each and every part in a very precise manner, okay. So today we are going to do the aluminum smelting part. Okay, so if you all remember from the last videos, okay, we have started with the metallurgical industry, okay, in the manufacturing industries chapter. Okay, so metallurgical industry we have covered the iron and steel industry, okay, and that's a very important subheading. Okay, the iron and steel industry is quite large too, and many positions come from there. Okay, even if it doesn't come this year, it is going to come in your class 11 or 12, okay, or maybe in your college level, it's obviously going to come from there. Okay, it's so damn important. But after the iron and steel industry, if there's any metallurgical industry that we have to study, it is the aluminum smelting part. Okay. Now, aluminum smelting is the second most important metallurgical industry of India. Okay, and this is the reason why this subheading is very important. But yet, the aluminum smelting part is very less compared to the iron and steel industry that we covered. In iron and steel industry, we covered almost everything. Okay, there were terms that were quite difficult to understand, and there were lots of we had to study about the problems, and we had to study about the location and everything. But in the aluminum smelting part, we do not have to study how many tons of this and that is made. Okay, so we do not have to cover so much of like we did in the iron and steel industry. But yet this chapter is very important. Okay, and so I want you all to understand this chapter rather than just study. Okay, because if you understand this chapter now, you will be saved from you will save a lot of time from studying this. Okay, and if you understand this chapter now, I bet a random revision on this subheading will do your job. Okay, so that you don't have to waste your time studying again all of this aluminum smelting and all. If you understand this here in this video, okay, so you don't have to study it again, just a revision will do. Okay, so this is what our motive will be. Okay, so we will take everything very slowly, precisely, and we'll try to understand this subheading. Okay, so let's start with this. So today we are going to do the aluminum smelting part of the metallurgical industry of the chapter manufacturing industries. Okay. So first thing that we need to understand here, okay, and that I've given as an introduction. So we are studying the aluminum smelting part. Okay, so let's understand what an aluminum actually is, right? Then we are going to understand what a smelting actually is. So the general introduction, and this is the definition that you'll find it in everywhere. Okay, in Wikipedia or your chemistry book or your physics book or whatever book you pick up, this is the answer that you are going to get. What is an aluminum? Aluminum is a chemical element with the symbol Al and atomic number 13. It is a silvery white soft and ductile metal in the boron group. Okay. So from this few sentences, okay, from this three line, we understand that aluminum is chemical element, okay, and it has a symbol Al, okay, and its atomic number is 13, okay, and it falls under the boron group, okay, and this is the reason why it has much of the characteristic of the boron elements. Okay, now what are the characteristics of the boron elements? Like they are very corrosive, they are good conductor of electricity, okay, and they are soft, they are very reactive, okay. Now a boron itself is not soft, but others are soft, okay, so but other elements in the boron groups are soft. So that is the quality that the aluminum has acquired as well, okay, as aluminum falls under the boron group. So just like any other boron group, it is soft, it is good conductor of electricity, and it is very reactive. Okay, now boron itself is not reactive, but the other boron, but the elements on the boron group, they are very reactive. Okay, so that is the characteristic that the aluminum itself has also acquired. Okay, other than that, then what we have to notice here is it is a very soft metal. Okay, and it is a very ductile metal. Okay, now how to understand what a ductile actually is? Now, a ductile refers to those metals or anything, any substances that can be just turned around from here and there, that you can fix the shape, that you can change the shape. Okay, let's say it's very soft. Okay, let's say it's not very hard. Okay, it's not very hard. It will change its shape. Okay, now we are talking about the natural aluminum. Okay, the natural aluminum that we get. Okay, so it is very ductile and it is very soft. Okay, so this is the kind of definition that we have. By mass, aluminum is the most abundant metal in the Earth's crust. Okay, now we need to understand this. How is it the most abundant metal in the Earth's crust? Bauxite. Now, aluminum comes from the ore bauxite. Okay, so what is the ore of aluminum? It is bauxite. What is the ore of iron? It is iron ore. Okay, now iron ore is a mixed version of iron and other elements. Okay, so we need to take away the iron, we need to extract the iron from the other elements, and then we'll get iron, isn't it? That's what we did. That's what we did in our last video. If you can check it again. Okay, so we inserted all of this iron ore into a blast furnace, and then we burned it. Okay, and then we got the iron in a molten form. Okay, now about this aluminum, we get the aluminum in a raw form in the bauxite. Okay, so bauxite is the ore of aluminum. Now from here we need to extract the aluminum. Okay, so this process is known as aluminum smelting. But then, if you need to understand how is it so abundant in the Earth's crust, bauxite covers almost around 8% of the Earth's crust. Okay, so it's present around almost everywhere. And it's in the rock, it's in the soil that we use, it's in the clay that we use. Okay, so aluminum is there almost in 8% of the Earth's crust. Okay, almost in 8% of the Earth's crust, and it is the third most abundant element after oxygen and silicon. Okay, so aluminum is not that it's very rare; it is there. Okay, so you just need to extract it from the bauxite. Okay, that's the only thing needed, and that extraction is called aluminum smelting. So in this whole chapter, we are not making a car, we are not making a vehicle, we are not making an aeroplane. What are we doing in the aluminum smelting? We are taking out aluminum from the bauxite. That's the only thing that we are doing, and that thing is called the aluminum smelting. We are taking out aluminum. Bus, that is aluminum smelting. Okay, don't imagine that we are going to make aluminum car and all. No, we are not going to do that. We are just extracting aluminum from the ore, and that ore is bauxite. Okay, so the chief ore of aluminum is bauxite. Okay, aluminum is abundantly present in the Earth's crust. Okay, and to be very precise, it covers almost 8% of the Earth's crust. Okay, aluminum smelting refers to the extraction of aluminum from the aluminum oxide. Okay, so from the bauxite, when you extract the aluminum, it's not completely aluminum, it's in the form of alumina or the aluminum oxide. Okay, now again, when you go through certain processes, that you don't have to study here. Okay, but I'll try to explain it. When you go through a certain certain processes, and then you remove the oxide, and you will get the aluminum. Okay, so they are in a 3 stage. Okay, just check here. Okay, from 4 to 6 tons of bauxite, you get 2 tons of alumina. Okay, so now this is alumina is in a very middle stage. Okay, you do not have a complete aluminium. Okay, you do not have a complete bauxite, so it's in the middle. So you need to purify it more. And so when you purify it, of course it has oxides, and you are removing the oxides, so of course it will decrease in its weight, isn't it? So first you add 4 to 6 tons of bauxite. Now bauxite has so many other minerals. Okay, they may have oxygen, they may have carbon, they may have sulfur, and they may have aluminium. Okay, now when you extracted only the aluminium, it got decreased. Okay, the weight got decreased. Okay, so it came to 2 tons of alumina. Okay, now alumina is also not very pure, so you need to extract more, and from there you extracted 1 ton of aluminum. So you see the weight is decreasing. Okay, the weight is continuously decreasing from the bauxite to alumina and then aluminum. Okay, so these are the 3 stages of how you get the aluminum. Now this process is the aluminum smelting. Okay, from bauxite you get the aluminum. Okay, so we are not talking about the size and shape of the aluminum, we are just getting the aluminum. Okay, so let us understand then how do we get the process in a very manufacturing manner. Okay, like they do in the industry. Now this is just haphazard way. Okay, and now there are three types of processes for how you get the aluminum. Now this process is just an easy way to explain it. Okay, so there are lots of electric way of getting aluminum, and there are so many other ways. But this is just a general process of showing how you get the aluminum, just to make you all understand. Okay, so things may differ in actual than in this diagram. Okay, so first you have the bauxite. Okay, and how do you get the bauxite? You get by bauxite query. Now, what does the meaning? What does the word mean as query? Bauxite query. What does it mean? It means nothing but you are just extracting bauxite from the ground. Okay. Now, bauxite is there in the Earth's crust. Aluminum is there in the Earth's crust that I said. So, aluminum is there in the presence of bauxite in the Earth's crust. So, you just have to go there and you have to extract it. You have to dig it or you have to swipe it. Okay. So, there are certain processes for that, and that is called bauxite query. Okay. So, you get the bauxite, and that bauxite is your raw material. Then it is shipped. Okay, it is shipped to the industry. Okay. From there, the bauxite is crushed and alumina is dissolved out. Okay, so now what does the word dissolved here means? It doesn't mean that you are washing off the alumina. No, it doesn't mean that. It means that the alumina is separated from the bauxite. You are crushing the bauxite, okay, and from there, whatever the alumina, maybe it has some certain difference in the physical characteristic that is recognizable. So that's why you are just extracting the alumina. You are separating the alumina from the bauxite, okay. Now, bulk of this alumina is shipped to the smelter. Okay, now here you come to the smelter. Now here lots of electricity is needed because electricity is used for giving heat here. Okay, so in a way you just want your aluminium to come out as in a molten form. Understand this, when iron was heated in the burst furnace, it was taken out, it was extracted in the molten form. And now here when you are putting too much of electricity, that means you want heat, okay? So the aluminum will come out in the molten form. Okay, so this is how it will get extracted. Okay, you use cryolite or molten metal acts as an electrolyte. Okay, so for the electricity to increase its intensification, okay, to get more intensified, they use cryolite. Okay, one type of mineral. Okay, that is highly electrolyte. Okay, that increases the intensity of the electricity. Okay, so now the electricity is already high, 18,000 kilowatt per ton of ore. Okay, now this is a very high amount. So you are using a lot of electricity here, okay, and then you get the aluminium. You separate the aluminium oxide, you separate the oxide from the aluminium, and you get aluminium in the form of a liquid. Okay. Now this is just a general process of understanding. Okay, but still this diagram is going to be very important. Okay, now this diagram is kind of a little bit complicated, but I hope you understand it now. The bauxite here, and then bauxite is the raw material. And then it is shipped to the some industry, okay, from where the bauxite is crushed and the aluminum is separated. Alumina is separated, okay, and from here it is processed to the smelter, and from smelter a lot of electricity is given. Cryolite acts as an electrolyte, okay. It's a good electrolyte, okay, so it intensifies the power of the electricity, and then you get aluminum in a molten form. Okay, it's just that to simply understand. Okay. After that, now this all are a thing. Okay, whatever we did till now, we understood aluminum, we understood bauxite. Okay, we understood how we get aluminum from the bauxite. Okay, that was just a process. Okay, now that's not how the exact process is, but that's just how a rough estimation is. Okay, that's just how we understand things. Let us understand now what are the features of aluminum. Now, what are the features of aluminum that we have already discussed is pure aluminum is soft, ductile, and has a high electric conductivity. Okay, it has a high electric conductivity. Please delete this. Okay, so it has a high electric conductivity. Now, pure aluminum that we get from the bauxite, okay, it is very soft. Okay, it is very soft. It is ductile. It can be shaped into anything that you want. It is not hard and has high electric conductivity. Now, high electric conductivity. Now, all of the elements in the boron group, they are very good conductor of electricity. Okay. Now, other thing than this is that the melting point of aluminium is also very high. It's around 658 degrees Celsius. Okay, so when you have a high melting point and when you are a good conductor of electricity, that means that this aluminum acts as a very good in the wiring parts, right? So aluminum can be used in the wiring. It can be used in a wiring, and it can be a very efficient way to be used in a wiring. Okay, but still we use copper. Why? Because copper is much more better choice. Okay, copper is much more better good conductor of electricity, and it has a much more higher melting point. Okay, so copper is much more better, so that's why our first option is copper. Okay, but still, in some places in the high tension wire where the electricity has to travel from a long distance, they use aluminum wires. Okay, because copper is kind of heavy, and you don't want the wires to hang. Okay, so and aluminum is very light, so in high tension wire from where you have to transfer the electricity to a long distance, at those places they use aluminum wire. Okay. So, but still we we get a general picture of the feature of aluminum. It is very soft, it is ductile, it can be changed into any form, and it is very high electric conductivity. It has a high electric conductivity, and also one point that it has a high melting point. Okay, it has a melting point of 658 degrees Celsius. So from here we kind of get a picture like in what an aluminum can be used, isn't it? So, but still, the pure aluminum is soft and ductile. Okay, that this 2 point is not good for any use. Okay, it's not good for any use. So you want your aluminum to be a little bit harder, right? The thing we started to use metal was from our forefathers. We started to use a stone and then wood, and then we went to bronze and we started to use metals. Okay, we started to invent iron and steel, and we started to use metals. Now, what was the need for extracting all of the metals? What was the need for doing all of this hard work? We did all of this hard work because we wanted to use something that was really very hard. Okay, that was very hard and that was very strong. Okay, now pure aluminum, which is not very strong and which is very ductile and which is very soft, you don't want to use that, isn't it? What's the use of using a metal which is not even hard, which is not even strong? So the pure aluminum needs to be alloyed. Okay, it needs to be mixed with other minerals, other elements. Okay, that is the terms for alloy. Alloy. That is what does alloy mean. So when you get bauxite, and from bauxite you get the alumina, and from alumina to aluminum, while you change it, you mix it with a lot of alloy like chromium, nickel, magnesium, silicon. Okay. Now these are some examples of the alloy that is mixed in the alumina to make the aluminum very, very strong. Okay, very strong and very hard. Okay, but still it's not that hard as iron and steel, but still it is much more harder than its pure form. Okay, so it needs to be alloyed. Alloying is very important. Okay, so again, from bauxite you get the alumina. Okay, maybe in the aluminum in the oxide form. Okay, and from there to get the aluminum that we can use, we need to mix it with alloys, and name of those alloys are chromium, nickel, magnesium, and silicon. Now, chromium, nickel, magnesium, and silicon is mixed in the aluminum to make the aluminum very strong. Okay, so alloying is very important. Now let's talk about the localization. Okay, so I hope I am clear till there. Okay, we haven't touched the Indian part. We just talked about the aluminum in a general perspective. Okay, we talked about aluminum in a general perspective, how we get it, what is it. Okay, I just wanted you all to understand it before we talk about aluminum smelting in India. Okay, now let's talk about localization. From localization, I mean where is the aluminum industry, smelting industry is found. Okay, what are the characteristics for the aluminum smelting industry to form? So before understanding that, let's understand what are the things needed in the aluminum smelting industry. Production of 1 ton of aluminum requires approximately 6 tons of bauxite. So bauxite is the raw material here. So you need 6 tons of bauxite to create 1 ton of aluminum. Okay, you are getting a picture now. 0.26 tons of caustic soda, 0.09 tons of lime. Okay, so even if you forget this, okay, even if you forget this, and high electricity. Okay, you need a very high electricity. You need around 18,573 kilowatt of electricity to produce 1 ton of aluminum. Okay, 18,573 kilowatt of electricity to produce 1 ton of aluminum. So, which are the two most things that are needed here? It is the 6 tons of bauxite and the high amount of electricity. Okay, so if you are an industrialist, okay, if you are an industrialist and you know that the cost of transportation is very high of bauxite, okay, now bauxite is not just that you can just take 1 kg or 2 kg. You need 6 tons of bauxite to make 1 ton of aluminum. So you need it in bulk. So you as an industrialist, you know that the transportation cost is very high uh, for the transportation of the raw material, for the transportation of the bauxite. So what will you do? You'll do a very clever thing, and that you will establish the aluminum smelting industry in a place where you get the bauxites, okay, where the bauxite is mined, isn't it? So that the transportation cost is reduced, okay, because you can transport 1 ton of aluminum in a very cheaper manner than to transport 6 tons of bauxite, isn't it? Transporting 6 tons of bauxite for a long distance is quite expensive. Rather, you would want to opt for transporting 1 ton of aluminum for that time. Okay, so this is one thing that you can do. Or the other thing that you can do is you can shift it to a place where the electricity is quite good, nearing to some dam. Okay, nearing to a place where there is a lot of river system. Okay, a lot of water system and all, so that the electricity availability is also quite high. Okay, why? Because it requires 18,573 kilowatt of electricity for making 1 ton of aluminum. Okay, and that's going to be very costly. So costly that almost 30 to 40% of the production cost of aluminum is accounted for its electricity cost. Okay, so 30 to 40% of the cost of the aluminum, okay, is included for its electricity cost. Okay, so you would want your aluminum smelting industry to be in a place where you get a good amount of electricity. Okay, so that you do not have electric fluctuations and all, so that you can produce the aluminum in a very good amount, in a very normal amount, okay, so that there is no other harm done. Okay, so you would want to do that. For the location, so you will either look at the bauxite, availability of bauxite, or the availability of electricity. Okay, now these are the two important factors that you will localize your industry upon. Okay, clear with this? Then let's move to a new thing. Okay, and this is the growth and development. Now we are entering into the Indian part. Okay, but unlike in the iron and steel industry and the agroforest, in the agro-based industry, we don't have to look so much into here. Okay, these all are not even there in your book. Okay, it's not even in your syllabus, but it will be much more better if you understand it in a very well manner. Okay, if you understand aluminum in a well manner now, okay, to save ourselves from studying it in the book. Okay, so what are the things that we need to understand here? Okay, so we are talking about the growth and development here. Let's understand then how in India there was a growth and development of the aluminum production in India. Okay, so that's the only thing we are looking here. That's the only thing we are seeing here. So the manufacturing of aluminum as a metal started in 1886. Okay, not in India but in the world. Now, for here, I just want to say you, okay, a fun fact that aluminum, people have been using aluminum for a very long time. Okay, and we didn't even realize it. If you go around 5,000 years back, 6,000 years back, when our Indus Valley civilization was there, and when people started to make potteries, and when the Persian Empire, they started to make potteries, they used clay, right? And in Earth's crust, 8% of our Earth's crust is bauxite, okay, and has aluminium. So when they used clay, they used aluminium in a certain manner that they didn't even realize. Okay, so we have been using aluminium, but we didn't realize that we are using it. Okay, aluminium was not discovered, let's say. Okay, but we have been using aluminium from a very long time, because aluminium is there in our Earth's crust for around 8%. Okay, and that's a very high amount. So maybe in the pottery and any artisan thing that our ancestors made, like for clay and all, even for making their homes and all, they used aluminium that was there in the mineral of that clay. Okay, that was there as an element in that clay. Okay, now aluminum is so highly reactive that it can stay in any environment and become hostile. Okay, you won't even recognize it. Aluminum is so reactive, and aluminum is not effective to any plants or human life. Okay, it doesn't have any bad effect for any plants or human life in its natural form, at least. Okay, so it can just be there and no one will recognize it. Okay, no plants will get any harm or effect or anything from that aluminum in the pure aluminum form, in the form of the bauxite that is there. Okay, so maybe we have been using it. Okay, not maybe, of course we have been using it in the clay and other stuffs for making our homes and all in the Indus Valley civilization from that, okay, from that area. Okay, but we hadn't noticed it in a very different metal, as a very different metal or as a very different element. Okay, it was there in a disguise. Now, the manufacturing of aluminum as a metal started in 1886. Okay, now what happened, especially from the 19th century, is now people from the 19th century they started to be a little bit modern. Okay, and especially there was a World War. Okay, especially in the 19th century and the 20th century, we saw now wars, lots of wars and world wars and all. Okay, now people started to invent a lot of new inventions. Okay, they started to make cars, they started to make motor vehicles, bikes, and especially the aircrafts. Okay, now the story of aircrafts is such that they wanted something to fly, a metal to fly, but steel was quite heavier. Iron is out of question. So they were in search of a metal that was quite lighter. Okay, and that's how they found out the aluminum. Okay, that's how they opted for aluminum. So the aircraft is made out of aluminum. Okay, it is much more lighter. Okay, and it is also very, as it is a metal, it is quite strong. Okay, you just can't go and chop it off. Okay, it's not possible that way. Okay. So after the World War, especially after the 19th century, in the 19th century, we started to recognize aluminum as an important element. Okay, and it started to be used in our utensils as well. From 1929, we started to use aluminum in our utensils and all. Okay, so this is kind of like a backstory for the aluminum. So from here, we understand that the manufacturing of aluminum metal started in 1886. Indian Aluminum Company started in 1928. Okay, now this was the beginning of the, 1938. Okay, so this was the beginning of the Indian Aluminum Company in India. Okay. Uh, Now, as I talked about in the World War II, okay, lots of aluminum production was made, okay, from the bauxite ore, okay, because people needed lots of motor vehicles, okay, because that was what the war was, okay, that was what the war was for. Technology, it was actually a war of technologies, okay. Lots of inventions were happening from that side and this side, from the allies and that side, okay. So one after the other. So this use of metals and iron and steel and aluminum, it just had a very big boom, okay. But the main starting, okay, of the aluminum company was from 1942, okay, when the Aluminum Corporation of India Limited was formed in Jaikai Nagar in West Bengal. Okay, in 1942 and 44, what does this mean is in 1944, 42, the alumina was made. Okay, not in the pure aluminum form, okay, not with the alloy and all, but just the alumina in 1942. And in 1944, the aluminum production started to happen. The strong aluminum that we use, that production started to happen. Okay, now in middle, lots of other industries and all opened up. Okay, but we are going to study only the important ones. So Balco is the very important one. Okay, the Bharat Aluminum Company Limited, that started in 1965. Okay, and production started in 1973 and 75. Now again, 1973, the alumina production was made, and 1975, the aluminum production was made. Okay, at Korba in Chhattisgarh. Now about this, okay, Balco, it may come in a book that it's in Orissa. Okay, of course it's in Orissa, then in Chhattisgarh. So, but I have mentioned it in Chhattisgarh. So why is it? Because Korba, because not all, like if you all have understood in the iron and steel industry. Okay. Now, iron and steel industry is the main heading. Okay, but inside it, okay, you have so many, lots of plants, isn't it? You have lots of plants for it. Let me give you an example for that. Okay, now the Tata Iron and Steel industry. Okay, now this is the most important industry. But then inside that, you also have Dubari Steel Works. Okay. So lots of plants are there. Lots of plants can be there under one industry. Okay. So Korba is one of those plants. So Korba is a plant that was opened up in Chhattisgarh. Okay. Oh, I mean in Chhattisgarh the Balco was opened up at a place called Korba. Okay, in Chhattisgarh. Okay. So Balco is in Orissa. Okay. If the question, if you see it in the book or if you read it in anywhere, don't just get confused. Okay. Balco in Orissa, Nalco in Orissa, it's all fine. Okay. One of the plant is in Korba in Chhattisgarh. One of the plant is in West Bengal as well. Okay. So it doesn't mean anything very difficult. Okay. It's just about a plant. It's just like having 2-3 hands all around. Okay. Now after Balco, then we have the NALCO, that is the National Aluminum Company Limited, and it was started in 1981 in Orissa. Okay, so the Balco and the NALCO is very important, and that's why Orissa is the first. It ranks the first in the aluminum production in India. Okay, second comes the West Bengal, and then the Kerala, Uttar Pradesh, Chhattisgarh, Maharashtra, and Tamil Nadu. Okay. Now, that I saw in the book that all you have to study is the states, okay, name of the states. But here are something very important that you don't have to, that you can't miss. Okay, you have to understand this. But still, there is nothing much that I gave here. No description of any terms, this terms of production and all. Okay, that's just going to confuse you. So, and that's not needed here. Okay, but still try to remember the name of the states. Okay, and try to remember it in this order. Okay, because this is from the ranking: first, second, third, fourth, fifth, sixth, and seventh. Okay. Now about the imports. Okay, now why I wrote this, okay, you all will understand. So India imported $4.4 billion worth of aluminum from China in 2019 and 20. Okay. So now in here I don't have to tell you anything much. Okay. You are doing an SSC subject and you all will understand. So before this, let's talk about that the progress of aluminum industry was very slow, but from second 5-year plan, okay, from the introduction of some of the industry like the Indal and Hindalco, we started to emerge as a good aluminum production country. Okay, it was quite sufficient to us, but until then, it was from 2006 and 7. We kind of had a little bit shortages in the aluminum smelting, aluminum production. Okay, we had shortages in that, and one reason for that is because we have been using aluminum in a lot of different things. Okay, we are using it in utensils in cars, vehicles, and all. And as you can see, the cars and vehicles are just growing in number. Okay, but still the per capita consumption of aluminum in India is just 500 gram. Okay, and the US is in the top. That is 5.9 kilogram in the US and 3.6 kilogram in Brazil. Okay, now this is the data. Now, if we take aluminum in as something that we consume, okay, and if we take it in per consumption, okay, if we take it in per capita consumption, okay, then India uses, each one of us only use around 500 gram of aluminum. Okay, while in US, each one of them use around 5.9 kilogram of aluminum. Okay, so that means what? That the production of aluminum there uh, is high, of course, but the use of aluminum is also very high there. Okay, they make a tons of private jets and aeroplanes and vehicles and this and that. Okay, and that's all known. They make lots of machineries, okay, from aluminum. They make lots of utensils from aluminum, and that is the reason why the per capita consumption is also high in a country like USA, of course, because that's one of the most developed countries in the world. Okay, so that's acceptable from there. Okay, but still we are doing good. We have around 500 grams of per consumption. Okay, but our production is kind of lacking. Okay, and that we have to import it from China. Okay, and this is the recent report. Okay, India imported $4.4 billion worth of aluminum from China in 2019 and 20. Now, this is the most important thing that we need to understand here. So we did all of the aluminum and we did all of the struggle of aluminum, isn't it? So why do we took all of the struggle? Why do we even study that? Okay, why did we even study that? Why? What was the motive of taking out aluminum from the bauxite? Okay, because there are some uses for it. Okay, and that's some of the very important uses. So that is what we need to understand here. The most common uses of aluminum include transportation, construction, electrical, and consumer goods. Now I want you all to write the the points yourself, and that's why I just give you all the subheading. Transportation. Now aluminum is a very light metal, okay, compared to steel and iron. So this is a very quick way of transportation. When things are quite light, okay, it can travel in a very fast amount. Okay, that's the reason why the sprinters are very light in weight. Okay, cheetah and deer are very light in weight. Okay, because they can run at a very high speed. Okay, so aluminum being a very softer, being a very lighter metal, it is very fast in transportation, and this is one of the reason why the airplanes use it, the aircrafts use it, bullet trains use it. Okay, the aluminum, and nowadays even in Indian coaches they are made out of aluminum. Okay, if you have compared, okay, maybe I don't know if this generation saw this, but we know. Okay, previously it used to be of something else. Okay, it used to be a little bit harder. Now the coaches are been transformed to the aluminum bodies. Okay, the coaches inside all of the blockages and the divisions are made out of aluminum now. Okay, quite lighter. Okay, and quite faster for the train to move. Okay, because when things are light, you can just run around very freely. Okay, now for that, to understand this, of course, like carry your weight and try to run. Okay, your speed will of course decrease, and you will get tired as well. Okay. Now loosen up the weight, loosen up all of your weight and just run. Okay, you can run for a faster rate, isn't it? So that's the thing. So for transportation, the better way for transportation here is aluminum. Okay. Aluminum is of course also used in while making a cars and vehicles. Okay. So that is one thing. Other thing is construction. Now there are some very designer homes that are made out of aluminum, okay, because they are very thermally efficient. Now, what does that mean? Word mean thermally efficient? It is it is very cool in summer, okay, and it is very warm in winter, okay. And this is one of the benefit of making home of aluminum. They are very thermally efficient. It is very cool in summer and it is very warm in winter. Okay, now these are some of the designer homes. Okay, some of the museums in England are made out of aluminum. Other than that, you have the aluminum windows and doors and all. Okay, that is very prevalent now. Okay, especially if you have an AC, they have aluminum slab and all. Okay, that doesn't let the air to pass through and come in. Okay, so for construction now, it is being used in a very nice amount. Other than that, you have for the electrical, like I talked about now, just like any other boron elements. Okay, just like the quality of any other boron elements, aluminum is also a good conductor of electricity. Okay, so when you are a very good conductor of electricity and plus your melting point is around 658 degrees Celsius, you can run it as an electrical wire. Okay, and you can trust it with that. But still we use copper because copper is a better option than aluminum. Okay, it is a better conductor of electricity. It has a much more higher melting point. Okay, but copper is a very heavy metal compared to aluminum. Okay, so when you have a very high tension wire, when the wire is connected from one point to the other point at a very long distance, those very heavy wires are not very sufficient. Okay, it will hang. Okay, so the better option here is using the aluminum wire. Okay, so in that way you can use aluminum wire for electrical wiring. Okay. So other than that, then we have consumer goods. Okay, like for consumer goods, I mean, just look at your mobile phones. Okay, iPhone or OnePlus or anything. Okay, nowadays a good mobile phones comes with your aluminum body. Okay, because it is hard. Okay, it won't break. They say it's much more lighter to feel. Okay, it looks good as well. So mobile phone is one thing. Then you have other things as well that is made out of aluminum. Okay, that you have a cartridge. Okay, that you have the wood, aluminum planks. That you have the even the store, even the big stores in the supermarket. Okay, they have the aluminum racks, isn't it, for where they keep the goods. Okay, so we use aluminum almost every day. Okay, so this is some of the benefits of aluminum, some of the uses of aluminum. So with this we end your chapter. Okay, the chapter is not very hard, it's very easy. Okay, and there's nothing more to study even. So just understand this. Okay, if you all have any problems, then text me, and just go through a revision when it's needed. Okay, And just try to understand this chapter, because if you understand the easy part, you can keep your time for the harder part. Okay. Okay then guys, just let me know if you all are very clear with this subheading. Okay.